Up the notes. I'm not going to make you use a graphing utility to graph the continuous function y of x. You don't have to if you want to. You could use Desmos if you'd like, but I'm not going to make you have to do the graphing utility part. I just want you to be able to solve the differential equation given the initial value problem. So initially what we're doing is we have a piecewise defined function where we have two cases where we have dy over dx is equal to 2y, and not equal, but plus, I don't know why I keep doing that, plus 2y is equal to f of x, so it's equal to 1 if we're between 0 and 3, or we can say dy over dx plus 2y is equal to 0 if we're greater than 3. All right, so let's go ahead and solve this differential equation for both sides. So let's go ahead and it's not going to be too bad. We need to notice, okay, what is our, p? Our p is 2. So we have e to the integral, and it's going to be 2, and then dx. So let's go ahead and integrate that. We're just going to get e to the 2x for our integrating factor. All right. And so then for the one above, we'll just say, okay, well, then we have e to the 2x times y dx equals, and then on the right-hand side, it's going to be e to the 2x times 1. Now, we got to integrate both sides here. So we're going to integrate. And when we integrate the left-hand side, we're just going to get e to the 2x times y. And on the right-hand side, we're going to get, when we integrate e to the 2x, that's just going to be 1/2 e to the 2x. And then we can say plus. Then we say c sub 1. Again, the reason why I say c sub 1 is because we've got the one on the right side as well that we have to take care of. Now, the nice thing about the right-hand side is our integrating factor is going to be the same. It's just going to be e to the 2x. And so when we, write this out, again, you could skip a lot of steps. It's going to be e to the 2x times 0. Now we integrate both sides. Integrate the left side and the right side. What's going to happen is we're going to get e to the 2x times y on the left-hand side, and that's equal to, we're going to get 0. The integral of 0 is just going to be a constant, so c sub 2. Now, we're going to go ahead and rewrite this as, okay, we know that both of these equal, y times e to the 2x, so y times e to the 2x is equal to, make sure that you know that that's an x, is equal to, and then we have 1/2 e to the 2x plus c sub 1, and that's between 0, where x is between 0 and 3, and then it's just equal to c sub 2 between 0, greater than 3, so x is greater than 3. All right, now let's go ahead and we already know, and this is we want to go ahead and focus on, okay, we know our initial value, and we have y of 0 is equal to 0. So we're going to go ahead and plug that in. So we plug that into, again, we're going to plug it into the first equation because that's in that interval between 0 to 3. So when we plug in y of 0 is equal to 0, we're going to be using that top equation. So we have, I'll just go ahead and write this out. So we're going to plug it into y e to the 2x is equal to 1/2 e to the 2x plus c sub 1. So we're going to solve for c sub 1. Plug in 0. So 0 times e to the 2 to the 0 power, that's just going to be 0. On the right-hand side, 1/2 e to the 0 plus 1, that's just going to be 1/2 plus, that's just c sub 1, not c sub 1, plus c sub 1, get that over, so c sub 1 is equal to negative 1/2. All right, so now we know what c sub 1 is. So we can say y e to the 2x is equal to the integral 1/2 e to the 2x minus 1/2, and that's from 0 to x. It's 3. We could pull out a 1/2 if you wanted to. Now, because this has to be continuous, all right, and we're not given any initial value for the first part, to find c sub 2, all right, c sub 2 is just going to be equal to our function 1/2 e to the 2x minus 1/2, because we already know what that is. But x has to equal, because it has to equal 3, so that this can be continuous. And so we're going to substitute that in and get e to the 6 minus 1/2. So then now this is equal to 1/2 e to the 6 minus 1/2 for continuity purposes. All right. So now that we know that, now we can just solve for y for both of these. And so then our final solution is going to be, we divide both sides by e to the 2x. And so we're going to get y is equal to the integral dividing everything by e to the 2x. We're going to get, I'll say we pulled out the 1/2. So we get, I'm not going to do that because I don't want y'all to get confused. 1/2 minus 1/2 e to the, since we're dividing e to the 2x, it's e to the negative 2x. And then on bottom, we're just going to have 1/2 e to the 6 minus 1/2. And then I'm just going to say that's all times e to the negative 2x. For x is greater than 3 and 0 is less than or equal to x is less than or equal to 3. Now you could write this a little bit differently, a little bit nicer. Y equals a little bit more clean, I'll say that. Put out the 1/2 and you get 1 minus e to the negative 2x. For 0 is less than or equal to x is less than or equal to 3. And then we could pull out a 1/2 and just get e to the 6 minus 1. E to negative 2x. Again, you didn't have to do that. It just makes it look a little bit cleaner. All right, so again, both of these are the same solution. Just one's a little bit more clean than the other. All right, so you can choose which one that you want to do.